Hello and welcome to the Section 11.1 lecture today for Algebra 1 Part 2. Today we're going to be looking at some geometry stuff. We're going to kind of get into that a little bit here as we wrap up this school year. So not a whole lot of days left. We are still going to have a couple of assignments, have some quizzes, but these are kind of our last two topics that we're going to get started here. So, taking a look at some definitions. We've got a lot of definitions today because we're looking at all the possible types of angles that happen when two lines intersect. And I guess when two lines intersect, that's a pretty good way to say it. So let's jump right into it. The first one we have is adjacent angles. These are angles that technically, the technical term would be that share a ray. And a ray is the side of an angle. All these should have arrows on them saying that they're going to go on forever. Just in the way that I built these, it didn't really come into play that way. So like angles 1 and 2 are adjacent angles because they share this ray right here. They share this side of the angle. And it makes sense if you think about what adjacent means, even in the English language. It means right next to. So I'm just going to, for all these, I'm going to try to just give one example. So we're going to say angle 1. Actually, since it's a pair, I'm going to say and. So angle 1 and angle 2. This little symbol that kind of looks like a less than, it's supposed to have a flatter bottom than a less than symbol, is our notation for angle. You might also see it with a little arc drawn in the angle as well. That's another variation. Neither one is better than the other one. It's just how you prefer to see it or how you prefer to show it. A linear pair would be two angles. And I'm actually going to add in there adjacent angles that form a line. So they form a straight line between those two adjacent angles. We really only have one example of a linear pair, and that's angles 4 and 5. They come together to form this whole line right here. Sorry. So we have angles 4 and 5 are a linear pair. Vertical angles, now this one's interesting because it's not talking about vertical as in up and down. It's actually talking about the point where the lines cross is called a vertex. So that's where this term vertical comes from. And vertical angles are angles across each other. That's two words. Each other when two lines cross. Okay, so when two lines cross, and I'm going to use some coloring here to really hone in on what we're trying to look for. So I've got my red line here, and I also have, this is always the hardest way to go. I don't know if anybody else has a hard time drawing into the center of their palm. Like as a right-handed person, I'm going this way to make that line. That's why I always struggle with lines with a negative slope, especially on here, because I can't really turn it and see where I'm writing and have it really make sense. So I apologize for that. But anyways, I have these two lines cross, this red line, this blue line. Angles 1 and 4 are across the vertex from each other. So they are vertical angles. Okay, so my example here would be angle 1 and angle 4. They're actually my only pair of vertical angles because of this weird third kind of, it's not really a line, it's just a ray. It starts at that same vertex and goes off in another direction. So that's okay. But angles 1 and 4 are our vertical angles, the only two that we have here. Complementary angles. The verdict's kind of out on this, but I would say that it's 2, and specifically 2. And I want to take this back. They don't have to be adjacent. Just 2 angles that, and in the old form, it would say that add up to a right angle. We're just going to say that add to 90 degrees. Believe it or not, before they came up with degrees, they measured everything in right angles because they knew what that was. They could visualize that. They knew what a right angle was, and they knew what a straight line was, and that's about all they had. So if we want 2 angles that add up to 90 degrees, it's actually angles 1 and 2, because the blue line and this line here with angle 3, that makes a right angle. Angle 3 is a right angle. So this is also a right angle over here. If I bring 1 and 2 together, they form a right angle. So angles 1 and angle 2. Now, the trick with complementary angles is that they don't have to be adjacent. Okay, that's usually how we're going to see it, but they don't really have to be side by side with each other. There could be some, I don't know why you'd ever put it, but there could be some space in between. If I have this angle, it goes this way, and then I have another one right here, and they happen to add up to 90 degrees, they would be complementary. Okay, then supplementary angles are 2 angles. And my pen's lagging out a little bit, but they 2 angles that add up, that add to 180 degrees. Okay. So 2 angles that add to 180 degrees. And again, the verdict's kind of out whether supplementary angles have to only be 2 angles. It's mostly seen that way. I kind of argue the other way and say, well, I could say that 1, 2, and 3 are all supplementary angles because the 3 of them together, but there are some definitions that fight that a little bit. So I'm going to stick with those, and mainly because they're the more common high school level definitions. I might be mistaken. That happens, but I feel like I've talked about sets of 3 angles being supplementary before, but again, I might be wrong. In our example, really all we have is angles 4 and 5 under that requirement. So angle 4 and angle 5. Those are supplementary angles. So that kind of brings into the question, well, what's the difference between supplementary angles and a linear pair? And really, there's nothing. Except for, I would say, possibly one thing. And that is, maybe supplementary angles don't have to be adjacent. They can have this kind of a relationship. If I've got one angle that's this big, and another angle, not that wouldn't make sense. Trying to do the best I can here. And another angle that looks like this, if they added up to 180 degrees, then you could argue that they're supplementary angles, but they're not a linear pair because they're not adjacent. Sure, you could make them adjacent, then they would be, but that's the only possible difference. So what we want to be able to do today is find measurements of angles. And so I'm actually going to go back through here and look at some special qualities of some of the angle pairs that we have. And so adjacent angles, there's really nothing special with that. They're just two angles that are side by side. That definition kind of sets up a lot of the other ones. A linear pair, because angles 4 and 5 are a linear pair, the measure of angle 4 and we denote that by M angle 4 plus the measure of angle 5 equals 180. So two angles that form a straight line equal 180 degrees when you add them together. The same thing ends up being true for supplementary angles. And I can just say that same thing again. Measure of angle 4 plus measure of angle 5 equals 180. The reason we use this little M, angle, whatever, technically you can't add angles. When you start talking about the measurement of an angle, that's when you're talking about how many degrees it has. If I just said, as I did in all these, angle 1, that means angle 1, the object, not how big it is, not anything about it other than just it's that object. So trying to get notation right, we want to put an M in front of our angle sign to mean the number of degrees that angle has. Complementary angles, they add up to 90 degrees. It's kind of said that way in the definition. And for those ones, we had angles 1 and 2. So the measure of angle 1 plus the measure of angle 2, they add up to 90 degrees. For vertical angles, when angles are across from each other, like 1 and 4, they're actually equal to each other. Measure of angle 4 equals the measure of angle 1. In geometry, we call those two angles congruent. And because they're congruent, their measurements are equal. So those are the facts that we're going to use today as we get through these problems. So looking at the first one, I have 72 down here, and I'm trying to find the measure of angle B in all these problems. So I'm trying to find M angle B. Well, 72 and B are across from each other when these two lines cross. So they are the same. So if this angle is 72, angle B is also 72 degrees. Okay? A lot of students, especially early in their math work, love geometry because at more of a basic level, the calculations are easier. Okay? And that is okay. The next one, 136 and angle B form a linear pair. So they add up to 180 degrees. 136 plus the measure of angle B equals 180. Now, I hate to break it to you, but there's algebra involved. We want to solve for the measure of angle B. And so when I subtract 136, I'm going to get 44 degrees for the measure of angle B in that problem. On the next one, the relationship that we have here is that these two angles are side by side and they form a right angle between the two of them. So they're going to add up to 90. Measure of angle B plus 67 degrees will equal 90. Another algebra type problem. I'm subtracting 67 on both sides. And the measure of angle B is equal to 23. All these answers should have degrees on them just to be completely correct. This one's a little tricky because the angle B and 30 technically aren't anything special other than the fact that they are adjacent. And then we're going to use one other fact. A trip all the way around a circle, if I start on this line and I go all the way around back to this line, that covers 360 degrees. So the measure of angle B plus 30 plus the given 294, those three angles added together equal 360 degrees. All right, so let's find the measure of angle B. Oops. I'd do a little work before I get there. That's going to be 324, so plus 324 equals 360. Yeah. So we subtract 324. And we get measure of angle B is equal to 36 degrees. And then this brings me to another point. Don't really assume that any of these are drawn to scale. So far, they haven't been terrible. This one, it's kind of questionable whether or not B is bigger than this 30-degree angle. I think it is. Is it 6 degrees bigger? Maybe. But don't say, well, it can't be 36 because it looks like the same size as 30. That's not a valid argument, okay, especially when I make the drawings. These two, they're complementary. They add up to 90 degrees. So the measure of angle B plus 43 is equal to 90. Subtract 43 from both sides. Measure of angle B is equal to 47 degrees. And for the last one, angle B and 74 are vertical angles. That means they're equal. So the measure of angle B equals 74 degrees. And that'll be it. Make sure you write down any questions you have over on the left. Otherwise, I hope you have a great day, and we will see you in class.